When you feel hungry, you take food. When you're sick, you take medicine. You take vitamins to keep you well. To decorate your house, you paint it, furnish it. And to beautify yourself, you use various cosmetic items. For washing, you use detergents and soaps. And to keep your environment clean, you use insecticides and germicides. In short, to make your life comfortable, beautiful, and easy, you use a large number of things. Some of these are natural and others are man-made. Dear students, did you ever think what these things are? Right now, there is a gas stove burning in your kitchen. This is natural gas which is burning. Natural gas is a mixture of organic compounds like methane, ethane, propane, etc. Or organic compounds are those compounds in which carbon atoms are covalently bonded to each other and to atoms of other nonmetals like hydrogen, oxygen, sulfur, nitrogen, and halogen. All other compounds are called inorganic compounds. But even inorganic compounds include a few compounds that contain carbon, like carbonates, bicarbonates, cyanides, and oxides of carbon. The branch of chemistry which deals with the properties, structure, and synthesis of organic compounds is called organic chemistry. Today, the number of known organic compounds is about 10 times more than known inorganic compounds. You can question, what is there about carbon that permits the formation of so many compounds? The answer is, carbon atom bonds with other carbon atoms to form all kinds of chain-like and branched shaped molecules. Carbon atoms also form stable bonds with certain other atoms like hydrogen, oxygen, nitrogen, sulfur, and halogens. Now look at the periodic table. You will see that carbon is in group 4 of periodic table. This means that carbon atom has 4 electrons in its outermost shell, and that is an open invitation to bond. A carbon atom can use all of its 4 electrons to bond with other atoms. In organic compounds, carbon shares its 4 electrons with other atoms to form strong covalent bonds. Similarly, there are millions of organic compounds which are prepared by plants and animals, and some are obtained from petroleum and coal. That's why we call living organisms as chemical factories. Besides that, thousands of organic compounds are being prepared by scientists. Some of those are same as those obtained from natural sources. For example, ethyl alcohol, and some other are purely synthetic and do not exist in living organisms. Soap, explosives, drugs are some examples. Consider an organic compound butane. Its molecular formula is C4H10. We can write its structure in 2 ways as 1 and 2. These are called structural formulas. A structural formula indicates how the carbon atoms are bonded to each other as well as the number of atoms of each element. As structural formula consumes time and space, therefore we can write the structural formula in a more convenient form called condensed formula. Note the difference between the 2 methods. You can see that in structural formula, all bonds are shown. In condensed formula, only bonds between carbon atoms are shown. You also notice one thing is common. Both have same molecular formula C4H10. Such compounds which have same molecular formula but different structural formula are called isomers. Structure 1 is a straight chain isomer of butane. It is also called as N-butane. Structure 2 is a branched chain isomer of butane, and it is named as isobutane. So far, you have learned that there are more than 10 million known organic compounds, an extremely large number, and you must wonder how one can name them. Dear students, for your convenience, scientists have developed a method of naming organic compounds, which was established as Geneva system in 1892 in Geneva and was revised in 1930. Now it is named as IUPAC system for naming organic compounds. We have said that there are more than 10 million known organic compounds. You may ask, can we classify this great number of compounds into groups? Yes. Most organic compounds can be classified into a few groups, which are called series. In these series, those compounds which react alike are placed together. Let's move in lab to confirm classification of organic compounds.
Dear students, we are studying about organic compounds. How organic compounds are classified. We can perform certain experiments to differentiate between these organic compounds. Dear students, if you have any question, you can ask. Organic compounds are classified into two major groups. One group is called aromatic and second group is called aliphatic. How can one differentiate between aromatic and aliphatic? Take a little quantity of the given organic compound and burn this organic compound on the flame. You see, a smoky flame is produced when we burn this organic compound. Now take the second organic compound and burn it on a flame. No smoky flame is produced in this case. So those compounds which produce smoky flame, such compounds are called aromatic compounds, and those compounds which produce non-smoky flame, such compounds are called aliphatic compound. Aliphatic compounds are further classified into two major groups, saturated and unsaturated. Saturated aliphatic compounds are those in which single covalent bonds are present between carbon atoms, and unsaturated compounds are those in which either double or triple covalent bonds are present between carbon atoms. We can differentiate between aliphatic saturated compounds and aliphatic unsaturated compounds by performing an experiment. Number one, test tube number one, take a little quantity of vegetable oil. In the second test tube, you take melted ghee, vanaspati ghee. Now add few drops of bromine water. Few drops of bromine water. In both the test tubes add few drops of bromine water. The orange color of bromine water is discharged in test tube number 1, whereas there is no change in the color of bromine water in test tube number 2. Those compounds which discharge the color of bromine water, they are called aliphatic unsaturated compounds, and those compounds which do not discharge the color of bromine water are called aliphatic saturated compounds. Aliphatic saturated compounds are also called alkanes. The general formula for alkanes is CnH2n plus 2. When we turn on a gas burner, we observe that a gas burns. Which gas is this? This gas is called natural gas. Natural gas is a mixture of various gases like methane, ethane, propane. The major component of natural gas is methane. If we take the difference of these two, it comes CH2. When we take the difference of these two compounds, it is also CH2. When two members of a group of compounds differ from each other by CH2, they are called homologies. And the group of compounds is known as homologous series. Aliphatic unsaturated hydrocarbons are further classified into two types. First type of compounds are called alkenes. The general formula for alkenes is CnH2n. Alkenes are the compounds which have double covalent bond between carbon atoms. The simplest example of alkene series is ethene. Common name is ethylene, whose molecular formula is C2H4. Ethene is used for the manufacture of polythene bags, plastic bottles, and in photographic films. Second type of aliphatic unsaturated hydrocarbons are called alkynes. The general formula for alkynes is CnH2n-2. The first member of alkyne series is called ethyne or acetylene, whose formula is C2H2. This compound has triple covalent bond between carbon and carbon. Acetylene is used for welding purposes. When acetylene burns with oxygen, it produces oxyacetylene flame. So far we have learned about aromatic, aliphatic, saturated and unsaturated compounds. These compounds mainly contains carbon and hydrogen. In addition to these compounds, certain other compounds are present which contain other elements in addition to carbon and hydrogen, like oxygen, nitrogen, sulfur, halogens, etc. Now let us perform some other experiments to know about certain other compounds. Now I take 6 test tubes. In the first test tube, I add one organic compound. In the second test tube, I add compound B. In the third test tube, compound C. Similarly, these 3 compounds are added in the other 3 test tubes. A in tube number 1, B in test tube number 2, and C in test tube number 3. Now make 2 sets of these test tubes. Set number 1, set number 2. In the first set, add Fehling solutions. This is Fehling solution A and this is Fehling solution B. But when we perform this experiment, we mix equal quantities of both the solutions, that is Fehling solution A and Fehling solution B. Yes?
So what's the difference between the Fehling solution A and B?
Aqueous solution of copper sulfate is called Fehling solution A. Mixture of rockly salt, which is sodium potassium tartrate and sodium hydroxide, is called Fehling solution B. This is mixture of Fehling solution A and B. Add this mixture of Fehling solution A and B in first set of test tubes. In the second set of test tubes, add alkaline sodium nitroprusside. Alkaline sodium nitroprusside. Now heat the first set of 3 test tubes on a water bath or water taken in a beakers.
So why we heat the 3 test tubes in this experiment?
In this experiment, we heat the 3 test tubes because each experiment needs certain conditions. Therefore, to carry out this reaction, we heat the 3 test tubes. The 3 test tubes, which contain 3 compounds, were heated on a water bath. You see that the colors in test tube 1 and 2 are similar. There are red precipitates, whereas there is no change in the third test tube. This shows that compound 1 and 2, test tubes 1 and 2 contain similar compounds, whereas test tube third, it contains a different compound. So in test tube number 1 and 2, the compounds are similar because the precipitates in both these test tubes are similar. When we see in the second set, there is no change in the colors of test tube number 1 and 2. There is red color in test tube number 3, which shows that compound in test tube number 3 is different from compounds in test tube number 1 and 2. In every molecule, there is an active part which is called functional group. This part of molecule has a special arrangement of atoms. Compounds having same type of functional group show similar chemical behavior. So in test tube number 1 and 2, the chemical behavior is similar, whereas the chemical behavior of the compound in test tube number 3 is different from 1 and 2. In test tube number 1 and 2, the compound taken is aldehyde. And in test tube number 3, the compound taken is acetone. The simplest aldehyde is formaldehyde. General formula of aldehydes is R C double bond O H. But there is one exception to this formula. In case of formaldehyde, instead of this R, which is alkyl group, hydrogen is present. Formalin is the first member of aldehyde group. Aqueous solution of formaldehyde is called formalin, which is used for the preservation of animals. You see, the animals are preserved in aqueous solution of formaldehyde. In addition to this, it is also used as an insecticide and germicide. Vanillin, which is used as a flavoring agent in vanilla ice cream, is also an aldehyde. The second type of compound in test tube number 3 are called ketones. The general formula for ketones is R C double bond O R. R stands for alkyl group. The first member of ketone series is acetone, whose formula is CH3 C double bond O CH3. It is used in paint and to remove nail polish. Another member of this series is acetophenone. Now let us perform some other experiments to know about some other organic compounds. Take 2 test tubes. In one test tube, Number one, you take one organic compound. In the second test tube, you take the other organic compound. Now we want to know whether these compounds are acidic or neutral. Dip a blue litmus paper in both the compounds. This litmus paper is blue. Now dip this litmus paper in test tube number 1 and in test tube number 2. Now you see the change. In test tube number 1, litmus paper changes blue to red, and there is no change in the second test tube.
Why the color of litmus paper changes from blue to red in case of test tube number 1 but not in test tube 2?
In test tube number 1, the color changes from blue to red, which shows that compound number 1 is acidic, whereas in test tube number 2, the compound is a neutral. Therefore, litmus paper changes from blue to red in test tube number 1. Compound in test tube number 1 is a carboxylic acid. General formula of carboxylic acids is RC double bond OH, where this R is an alkyl group. There is only one exception. In case of formic acid, there is hydrogen instead of alkyl group. So this is only one exception. When this acid is injected by ants and bees into the body of victim, the skin of the victim becomes inflamed. The second member of this series is acetic acid, whose formula is CH3C double bond OH. This acid is present in vinegar. The sour taste of vinegar is due to presence of acetic acid in vinegars. So far, we have studied about carboxylic acids, which was in test tube number 1. Now we see which compound is in test tube number 2. Now take a little quantity of this compound in a tube. Approximately 0.5 grams of hydroxylamine hydrochloride. And then add approximately 5 ml of 10% sodium hydroxide. Five ml of 10% sodium hydroxide. Now place this test tube in a cold water for 1 to 2 minutes. Now add a little quantity of dilute HCl in this test tube. Then add solution of ferric chloride in the tube. Now you see a reddish brown color, dark reddish red brown color is formed. This dark red brown color indicates the presence of esters. Esters are organic compounds whose general formula is R C double bond OR, where R stands for alkyl groups. The example of esters is CH3, C double bond O, C2H5. And the name of this compound is ethyl acetate. So far, we have studied about aromatic compounds, aliphatic compounds, aldehydes, ketones, carboxylic acids, and esters. Have you any other question?
At the end, it is very easier to summarize the whole program as: organic compounds are those compounds which contain carbon atoms covalently bonded to each other and with other non-metals like hydrogen, oxygen, sulfur, nitrogen, and halogens. These can be natural or synthetic. And so, organic compounds are very important in our daily life today. See you in next program. Allah Hafiz.